Okay. Hello, everybody. I am recording the section 3.2. I'm live with my Block 4 class. Do you want to give a little shout out, Block 4? Okay. So we're looking at 3.2 logarithmic functions and their graphs. So an exponential function is going to look something like this, but it will always pass the horizontal line test, so it will have an inverse function. And the inverse of an exponential function is going to be a logarithmic function. You have this definition of a logarithmic function on your gift. So basically it says for x greater than 0 and a greater than 0 and a not equal to 1, y equals log to the base a of x if and only if x is equal to a raised to the y. All right, when you see this, f of x equaling log to the base a of x, that's how you read this. You say log to the base a of x. Can you say that with me, please?
Log to the base a of x.
Perfect. So that's the logarithmic function with base a. I have put these equations also on your gift. So y equals log to the base a of x and x equals a raised to the y are equivalent equations. They're just written in two different forms. One is in logarithmic form and the other is in exponential form. All right, so let's see if we can follow the pattern here. Like, where does the x go? Where does the a go? Where does the y go? We're rewriting from log form to exponential form or vice versa. So if I have 3 to the 4th equals 81, which I think is on your gift, and we want to rewrite this in log form, that means I'm going to have to fill in these boxes. Log to the base what of what is equal to what? Can you help me out with this, Dan?
Oh boy. All right. So with the
So Dan, if you're looking up here, what's the base here? What do you think is the base?
3.
3. So if I say log to the base,
Log to the base 3.
I probably want 3 there. Log to the base 3 of what?
4. Or
It's going to have to be the 81, and log to the base 3 of 81 is equal to 4. All right, here's how I want you to interpret this, because I want you to wrap your head all the way around these logarithms today. This is basically saying 3 raised to what power gets me to 81? Well, 3 raised to the 4th power is equal to 81. So that's why log to the base 3 of 81 is equal to 4. So let's go the other direction now. If I give you a logarithmic equation, I need you to write this one in exponential form. So what raised to the what is equal to what? Can you help me out with that, Casey?
2 raised to the power of 5 equals 32.
2 raised to the power of 5 is equal to 32. Do people agree with that arrangement?
Yes.
All right, so this is saying 2 raised to what power gives me 32? Well, it's 2 to the 5th. That's going to give me 32. All right, note, logarithms are exponents, right? So if logarithms are exponents, this is basically saying what exponent do I need on 2 to get me to 32? Does that make sense? All right, and this means log to the base a of x is the exponent to which a must be raised to obtain x. All right, so let's try this example. I want you to rewrite this logarithmic equation in exponential form. So I've got log to the base star of heart equals hexagon, and so I need you to write this in exponential form. Can you help me out with that? Audrey, start to the hexagon power equals heart. Do people agree with that?
Yes.
Yeah, this is saying star raised to what power gives me heart? It's star raised to the hexagon is equal to heart. Everybody okay with that?
Yeah.
All right, let's go the other direction. In this case, I've got p raised to the g equals s, and I'm asking you to rewrite this one in log form. Can you help me out with that? Michael.
Log
Say log to the base,
log to the base
log to the base p of s equals g. Do people agree with that?
Yes.
Gabby.
Is S like Is it written almost like an exponent, or is it like a normal?
You mean that S there? Yeah, I'm so, you get past for this.
That's 3 in a day.
You are El Fuego today, my friend.
All right.
Alright, so here's the deal with this. This should be log to the base P of S equals G. The log, the S, and the G should all be on one level, right? I think that's what you're asking, right? We don't want that S to be floating. It's the P that should be lower, the base should be lower, everything else is on one level. If you write this as log P, if you write it like this, I will mark it wrong. I cannot have that S kind of floating up because that's log to the base P of S. That's not what this is saying. All right. Okay. So what would be log to the base 4 of 16? Can you help me out with that one, Ryan?
All right. Oh, okay. So it is going to be 4.
To the mystery power
Yeah.
is equal to 16. So what would it be?
2.
2. Right? Everybody agree with that? Does that make sense? All right. So let's try a couple more of these. What if I have log to the base 3 of x as my function, and I want to know what's the value of the function when x equals 9? That's basically saying I want f of 9, which is equal to log to the base 3 of 9. Can you help me out with that, Jenna?
What were they again?
Evaluating log to the base 3 of 9,
Okay.
which means 3
3,
raised to what power gives me 9.
3 to the second power is on.
Yeah, so log to the base 3 of 9 is equal to 2 because 3 to the second is equal to 9. So my answer is 2. Are we okay with this?
Yeah.
All right, what about log to the base 2 of x when x is equal to 8? Can you help me out with that, Lexi?
3,
Why is it 3?
because 2 times 2 times 2 is 8.
All right, so this is, my answer is going to be 3 because 2 times 2 times 2, or 2 cubed, is going to be equal to 8. What about this one? Log to the base 5 of x when x is equal to 1. What's log to the base 5 of 1 going to equal? Nathan, can you help me out with that?
Yes. It is x or 5 to the power of 1/5 equals 1.
So is 5 to the 1/5 equal to 1? Because you're saying 5 raised to what power gives me 1? So is 5 to the 1/5 equals 1? I think 5 times 1/5 will give us 1, but we're saying 5 raised to what power is going to give us 1? Patrick, what do you think? 0? Nathan, what do you think of that idea?
Yeah.
Anything to the 0 power is equal to 1. So that's why our answer here should be 0. Are we okay with this? All right, what about this one? How about log to the base 3 of x when x is 1 over 81? So I would like log to the base 3 of 1 over 81. What's that going to be? Can you help me out with that? Nora.
Would that be 3 to the negative?
So we're trying to figure out 3 raised to what power?
Yeah.
Gives me 1 over 81, so 3 to what
That would
power?
be negative.
You think it's going to be negative?
Yeah, because it's 1 over 81.
1 over
It would be 3.
negative 3.
Yeah.
Is 3 times 3 times 3 equal to 81? No, Audrey?
It'd be a negative 4.
I think we're going to need negative 4 there.
How'd you know that?
Well, because 3 to the 4th is equal to 81, so 3 to the 1st is 3, 3 to the 2nd is 9, 3 to the 3rd is 27, 3 to the 4th is 81. Some of these I think, hopefully you know. All right, the logarithmic function with base 10 is called the common log function. All right, and it's denoted log base 10 or just log. So if you leave off the base, it's understood to be a common log. So, for example, evaluate the function f of x equaling log x at each value to 4 decimal places. So this one, though, I think we can do without a calculator. So log, whoopsie. If this is saying log 100, right, I'm plugging in 100 for x, Remember, that's the same as saying log to the base 10 of 100. If you don't see the base, it's understood to be a 10. Agreed? So what number would be log to the base 10 of 100, Kelly?
2,
Why 2?
because 10 squared is 100.
All right, so we'll say it's 2 because 10 squared gives us 100. Everybody okay with this? All right, let's try this one, but this one I think we're going to need our calculator. So we're going to do log to the base 10 of 1/5 on our calculator. So that's not what you wanted to see. Let's see. So here, if I go to a calculator page as you are doing, and I want to find the log button, I need to do Control and the 10 to the X key. And now I'm going to put in my base, which, thank you, TI Inspire, the TI-83 and TI-84. I don't know if they've changed it recently, but they only gave you 2 bases, 2 built-in bases, base 10 and base E, and that was it. So you can put whatever base you want in here. So thank you, TI Inspire. All right, so log to the base 10 of 1/5. I'm getting, what am I getting? I'm getting like negative 0.69897. Does that look right?
Yeah.
All right, awesome. And what about 3.25? I want log 3.25. Can you do that, please? This is saying 10 raised to what power gives me 3.25. So I'm doing log, base 10. Did you get 0.511? 883, okay. And how about log to the base 10 of -4? Okay, so we don't like that one, or the calculator is letting us down. Log to the base 10 of -4. All right, big warning sign. Not a real calculation. Because this is basically saying, is it possible that I can take 10 raised to some power and end up getting a negative number? No, I can't take a positive base to any power and get a negative number. So this one does not exist, which really helps us decide about logarithmic functions in general. If I have log to the base 10 of -4, that's no good, because this -4 has to be a positive number. You're not allowed to plug in negative numbers in a logarithmic function, right? What about 0? Try log to the base 10 of 0. So that's no good either. So the number after the word log has to be a positive number. All right, and we're going to see why that is in just a little bit. Moving on, though, here's some properties of logs, and I would encourage you to write these down in your notes, because I think you're going to kind of need these. So first of all, our first property, and we've already played around with this one, this says log to any base A of 1 is always going to equal 0. So for example, I think we had log to the base 5 of 1, and we said that was going to be equal to what? 0, and that would be because 5 raised to the 0 is equal to 1. Everybody agree? Yeah. All right. Next property says log to the base A of A is always going to be equal to 1, and that's because A raised to what power gives me A? A raised to the first gives me A, right? So if I have log to the base 10 of 10, this is saying 10 raised to what power gives me 10? 1. 10 to the first gives me 10. So anytime your base matches what you're taking the logarithm of, your answer is 1. All right. Here are 2 kind of related properties. This one says log to the base A of A raised to the x is just going to be equal to x. And we're actually going to look at this a little bit more closely in section 3.3. But the idea is that this power right here can actually come down in front of this logarithm and be multiplied by that logarithm. And so if I've got x times log to the base a of a, what did we just say log to the base a of a was going to equal? 1. So I really get x times 1, which is indeed x. Are we okay with this?
Yeah.
All right, and what about this this one? I got a raised to the log to the base a of x equal to x. Always going to equal x. Well, I think in order to reason out why this strange-looking equation is going to be true, is I would rewrite this from exponential form, because that's what I see a log in there, but it's really written in exponential form, and I would say, hey, let's rewrite it in log form, right? So if I'm going to rewrite this in log form, can you help me out with that? I want log to the base what of what equals what. Can you fill those spots in for me, Chris?
So,
Remember, it just looks like it is an exponential because I've got something raised to the something equals something, right? So it is an exponential equation, but I'm asking you to write it in log form.
it's gonna be log of log a,
So log to the base,
log to the base a of log to the base a of x versus a.
like if I have 5 to the second equals 25, I don't put the 5 here and the 2 here.
Oh, yeah.
So it's log to the base a of,
Log of, log of base a to b.
log to the base a of x, right? This x goes right here, correct?
Oh,
You with me?
yeah.
Equals, and this guy goes over here, right? Are we agreeing?
Yes.
Right? I need you to be able to go back and forth. So this is going to be log to the base a of x. Well, I've got log to the base a of x equals log to the base a of x.
Wow.
I guess we just proved it. Are we okay with this?
Yes.
We couldn't really see it in exponential form, but if we rewrote it in log form, there it is, popping out at us. All right, one more property of logarithms, and this one says if log to the base a of x is equal to log to the base a of y, then x is going to have to equal y. This is very closely related to our property, our one-to-one property, right, that we learned in section 3.1. This is basically saying if you've got log to the base a of something equal log to the base a of something, those two somethings have to be equal to each other. All right? Okay. So these are a few quick examples similar to using those properties. So, Kara, what's log to the base 5 of 1?
0.
0. All right. Log to the base anything of 1 is going to be 0. What about this one? Log to the base square root of 11 of square root of 11. Tiger?
Square root of 11.
Is this going to be square root of 11?
No.
Is it 1?
Yes.
Do people agree?
Yes.
Remember, that's because, take that base, square root of 11, raised to what power gets me square root of 11? And it would have to be 1. So that's our answer for that one. Let's take a look at letter C. I've got 8 raised to the log to the base 8 of 30. This should look like one of our properties. What's this going to be equal to? 30. If you want proof of that, let's take it from this exponential form and rewrite it in log form. So I want log to the base what of what equals what? Chris, back to you.
So it's going to be log of base 8.
8, there's my base. 8, log to the base 8 of 30 equals
log to base 8.
yeah, this whole exponent here, that whole exponent is my logarithm. So that's log to the base 8 of 30. So I get log to the base 8 of 30 equals log to the base 8 of 30. Are we okay with this? All right, and how about this one? Log to the base 5 of y equals log to the base 5 of 16. Kate, how do we solve that?
Is that x equals y or like 16 equals to y?
Yeah, so y is just gonna turn out to be 16. Everybody agree? All right, and you get the idea here. You would just set these guys equal to each other, right? Because it's basically log to the base 10 on both sides. Oopsie. And same thing here, set those equal to each other. All right, let's get to this. So we've got, I want you to compare the graph of log to the base 3 of x with with 3 raised to the x. Remember, exponential functions and logarithmic functions are inverse of each other. So if I have 3 to the x, let's start with that one. We graphed this last time, correct?
Okay.
Yes? So I know that negative 2 went to 3 raised to the negative 2, which ends up being 1 over 3 squared is 1/9. Yes? All right. 3 to the negative 1 is 1/3. If I plug in 0 here, I get 3 to the 0 is 1. 3 to the first is 3, and 3 to the second is 9. So we graphed this last time. I've got negative 2 going to 1/9. I've got negative 1 going to 1/3. I've got 0 going to 1, 1 going to 3, 2 going to 9, and I get this exponential growth curve like this. Are we agreeing?
Yeah.
Let's try a couple values here. Well, actually, I want to remind you, back in chapter 1, back in September, we learned about inverse functions, like in section 1.8, something like that. And we learned that if you have a function and you want to find ordered pairs on the inverse, you just switch those x and y coordinates. Remember that? So that means that really on my inverse graph, instead of negative 2 going to 1/9, 1/9 should be going to negative 2. And instead of negative 1 to 1/3, 1/3 should be going to negative 1. 1 should be going to 0. 3 should be going to 1. And 9 should be going to 2. All right? Can we test that and make sure I'm not just making this up? Like if I plug in 1 in here, I would have log to the base 3 of 1. What's log to the base 3 of 1? 3 raised to what power gives me 1? 0. So that one works. What about log? What if I plug in 9? What's log to the base 3 of 9?
2.
2. That one works. What if I have 1/9? What's log to the base 3 of 1/9? Negative. It all works, right? So if I'm plotting these, let me get rid of this so I can graph our function. So if I'm plotting 1/9 goes to negative 2, oh, that's right about here. 1/3 goes to negative 1. 1 goes to 0. 3 goes to 1. 9 goes to 2. And I'm getting this graph looking like this. If you remember from chapter 1, the special thing about the graph of an original function and the graph of its inverse is that they are mirror images over the line y equals x. Do you agree that this is a mirror image of this one over the line y equals x?
Yeah.
One of these functions has a horizontal asymptote, and one of them has a vertical asymptote. Which one has the horizontal asymptote? The exponential one or the logarithmic one? The exponential one. This one right here, this is the horizontal asymptote for y equals 3 to the x. It has a horizontal asymptote at y equals 0. This one here is my y equals log to the base 3 of x. And that one has a vertical asymptote, I'm abbreviated, at x equals 0. Does that make sense? Yeah.
So don't I have the other one too? Like, doesn't y3x have a vertical asymptote?
It sure looks like it's getting vertical, but it's never getting perfectly vertical because the further out I go, it still keeps going up. I can still keep going further and further. There's no place where I can't, the domain for an exponential function is all real numbers. So I could plug in 1,000,000, and granted it would be a huge number because I'd be taking 3 raised to the 1,000,000th power, but I can still find a point. It just keeps going and going. Chris?
So the vertical asymptote of n x equals 3 to the x, and the
The
horizontal asymptote of log-based apex are gonna be the same. They're gonna be like inverses too, or they're gonna be,
well, it just that the horizontal asymptote for an exponential function is going to be y equals some number, and the vertical asymptote for a logarithmic function is going to be x equals something. What you will see on the video for the 3.2 shocking conclusion video, right, is that we can mess around with finding the vertical asymptote. For example, if I had this as instead of x, if I had that like x minus 4, I'd be shifting this whole graph 4 units to the right. That vertical asymptote is going to shift 4 units to the right, so it'd be x equals 4. Does that make sense? All right, but if I shift this graph 4 units to the right, is that going to change my horizontal asymptote?
No.
No, but if I shift this graph up like 2 units, then that's going to shift up my horizontal asymptote up 2 units. Does that make sense?
Yes.
All right, so you'll see, we'll talk more about that on the video. All right, at this point, I look like I'm short a few phones here, folks. Cough them up. Cough them up. All right, thank you for watching.
Bye.